Okay, in this video we are going to talk about operations with radicals. Again, remember radicals is like square roots, cube roots, and we are going to learn how to add, subtract, and multiply them. So we're going to start off with adding, subtracting, and then at the end we will get to multiplying and dividing them. Okay, so we add and subtract radicals the same exact way that we add and subtract variables. So for example, if I had 3x plus 2x, the way I add those two variables together is I add the coefficients, the numbers in front. So I would do 3 plus 2. I know 3 plus 2 is 5, and so my answer is 5x. And I just kind of ignore the x, and I just throw it on at the end. Same idea with radicals. If I had 3 times the square root of 7 plus 2 times the square root of 7, since they're both square roots of 7, the idea here is I have 3 of these square roots of 7 here. I have 2 of them over here, so I can add them together. 3 plus 2 gives me 5 of my square roots of 7. So same idea, you just add the coefficients in front. That's for adding. Subtracting works the exact same way. So if it was 3x minus 2x, I would get 1x. 3 square roots of 7 minus 2 square roots of 7 would be 1 square roots of 7. And again, you don't have to put the 1 in front of either one of them. And again, you have to have this inside number has to be exactly the same. The same way this x has to be the same. If it was 3x plus 2y, you can't put those together. Same idea if it was 3 square roots of 7 plus 2 square roots of 6. You can't put those together. Okay? So essentially that's all there is to it. So let's do a few problems together, and I'll show you kind of where you have to do a little extra work. Okay, so our first problem, if we had 2 square roots of 10 minus 8 square roots of 10. So they both have the square root of 10, so I just subtract the coefficients, the number in front. 2 minus 8 gives me negative 6 square roots of 10, and that's my answer. If I had the problem 5 times the cube root of 3x plus 7 times the cube root of 3x. They both have the same radical, the cube root of 3x, so I can just add the numbers on the outside. 5 plus 7 is 12, and so my answer would be 12 times the cube root of 3x. Okay? Sometimes you're given a problem that seems like you can't do it, but you actually can. So for example, if we had the problem, the square root of 20 plus 2 times the square root of 45. Just by looking at it like that, you cannot combine those. Square root of 20, square root of 45, they're not the same. But if you kind of look a little further into it, you can simplify both of those and break them down so that they become a problem that you can do. So think about it. Square root of 20, I'm going to come over here on the side and I'm going to break down the number 20 and see if I can take anything out. So the number 20 breaks down into, you can start off any way you want to. I'm going to do 2 times 10, and 10 is 2 times 5. So the square root of 20 turns into 2 times 2 times 5. I can take out a pair of 2's out front, and so that's actually 2 square roots of 5. Okay, so I'm going to rewrite that over here in my problem. 2 square roots of 5 plus over here 2 times the square root of 45. 45 breaks down into 9 times 5, right? Yeah, 9 times 5 is 45. And so 5 is done. 9 can break down into 3 times 3. So 45, I'm going to put the 2 in front of it because remember it was 2 times the square root of 45. This is now 2 times, there's a 3 times 3 times 5 inside. I can take out my pair of 3's and put them out front. If there's already a number there, remember you multiply those two numbers together. So it would be 3 times 2, which is 6 on the outside. On the inside is a 5. So I'm going to write that over here. So this is 6 square roots of 5. And from there, now that I simplified those two radicals, I can do this problem because they both have the square root of 5. If I have 2 of these square roots of 5 and I add to it 6 square roots of 5, I get a total of 8 square roots of 5. And that's my answer. Okay, let's do a couple more like that. I'm going to turn the page, kind of ran out of room there. if I had the problem, this is number 4, I believe, the cube root of 54 minus the cube root of 16. As of right now, there is nothing you can do with this problem, but I bet I can break down 54 and 16 so that they become the same numbers so that I can combine them. So you come over on the side of your paper, the cube root of 54, so 54 breaks down into 6 times 9. 6 is 3 times 2, and it's done. 9 is 3 times 3, and it's done. Oops. So the cube root of 54 is 2 times 3 times 3 times 3. Remember, with cube roots, you have to take out groups of 3. So I'm going to take out one group of 3 3s and put it out front. So it's 3 times the cube root of 2 is what the cube root of 54 turns into. 3 times the cube root of 2. And then I want to subtract from that the cube root of 16. 16 breaks down into 4 times 4. Each 4 is a 2 times 2. So the cube root of 16 is 4 2s. Remember, I can take out groups of 3. I have 3 2s I can take out and put out front, so it's going to be 2 times the cube root of 2. So now, I'm going to write that over here, 2 times the cube root of 2. Now this is a problem that we can do because the roots are the same, cube root of 2, cube root of 2. I have 3 of them, I'm taking away 2, so that leaves me with 1 times the cube root of 2, or you don't have to put the 1. You can just write it as the cube root of 2. Whichever one you want to. It doesn't matter, same exact thing. Okay, so that is adding and subtracting. Essentially, that's about as hard as it gets. The only way this could get harder is if that was a bigger number and that was a bigger number and you have more things you can take out. Okay, so adding and subtracting, the big idea to remember is it has to be the same root. If it's not at the beginning of the problem, you probably got to break it down to get it to the same root. And more than likely, on your homework and test, they're going to work out to where you can get them as the same root. Like, you're not going to end up with the cube root of 2 and the cube root of 5 here, because then you can't do the problem. There was no point in doing all this. Okay, so let's move on to multiplying. Okay, so the big idea with multiplying radicals, the idea is you are allowed to multiply outside numbers together with other outside numbers and inside numbers together with other inside numbers together. Okay, so you multiply outside times outside and inside times inside. You can't multiply an outside and inside number together. Okay, so for example, the square root of 2 times the square root of 5. Okay, 2 is an inside number, 5 is an inside number. I can multiply those two numbers together and get a 10, and it's an inside number. So this becomes the square root of 10. Okay, if I had 2 square roots of 3 times 5. Okay, so notice this 5 is an outside number because it does not have a square root on it. This 2 is an outside number, so that's what I multiply together, the 5 and the 2. 5 times 2 is 10, and this inside number stays the same. It's still the square root of 3, so 10 times the square root of 3. Okay, if I had 2 square roots of 3 times the square root of 5 this time. The square root of 3, square root of 5, those are both inside numbers, so I can multiply those together, and I get the square root of 3 times 5 is 15. That 2 stays on the outside. If I had 2 times the square root of 3 times 5 times the square root of 5, in this case, I multiply both outside numbers together and both inside numbers together. So the outside numbers, 2 times 5, gives you 10. The inside numbers, 3 times 5, gives me the square root of 15. Okay, so I hope that helps explain the outside numbers together. You do outside times outside, inside times inside. You never do an outside times an inside. Okay, so to do these problems, the only way this gets harder now, this is the idea. You just combine that with the idea of distributing. Okay, so if I had the problem, let me move this up over, there we go. The square root of 2 times the square root of 3 minus the square root of 5. So to multiply this, I'm going to distribute. I'm going to do the square root of 2 times the square root of 3. The square root of 2 times the square root of 3, those are both inside numbers, so I get the square root of 6. Now I'm going to do the square root of 2 times the square root of 5. This is actually negative square root of 5, so it's going to be a minus sign. Those are both inside numbers, so I can multiply those together and get the square root of 10. And then the question is, can I subtract these? Okay, think back to how do we add and subtract radicals? They have to have the same root. Do these have the same root? No, they do not. Sometimes you can break them down and make them have the same root. Just a little hint, usually on these kind of problems you can't. Because think about it, 6 breaks down into 2 times 3, there's nothing I can take out. 10 breaks down into 2 times 5, there's nothing I can take out. So this is my answer. Okay, let's do some more of those. What about if I had the problem 2 times the square root of 3 times the square root of 5 plus 3. Okay, so again, I'm going to distribute. 2 times the square root of 3 times the square root of 5 is, the 3 and the 5 are inside numbers, so I'm going to multiply those together, and I get 2 times the square root of 15. 2 square roots of 3 times 3 gives me, the 2 and the 3 are both outside numbers here. So 2 times 3 gives me 6 square roots of 3. And, sorry, I circled it too fast. This is my answer. I can't put them together because they do not have the same root, and I cannot break them down and take anything out to get the same root. Okay, let's do one where we have to FOIL. If I had the problem 7 square roots of 5 plus 2 times 3 square roots of 5 minus the square root of 3. Okay, so I'm going to FOIL this out or double distribute, however you want to think about it. So the first thing I'm going to do is take the 7 square roots of 5 and multiply it by everything in the other parenthesis. So 7 square roots of 5 times 3 square roots of 5. 7 times 3 is 21. These both have inside numbers. 5 times 5 is 25. Okay, now my outside numbers. 7 square roots of 5 times negative square root of 3. It's going to be minus. 5 and 3 are both inside numbers, so it's going to be the square root of 15 on the inside, 7 on the outside. Okay, now I'm going to multiply the 2 by everything. So 2 times 3 square roots of 5, 2 and 3 are outside numbers, so it's going to be 6 square roots of 5. And 2 times the negative square root of 3, it's minus. 2 is an outside number, 3 is an inside number, so you don't get 6. Like, you don't multiply them together, you just get 2 times the square root of 3. From there, you see if there's anything you can simplify or combine. So if you look at this first part, 21 times the square root of 25, can I take the square root of 25? Yes, I can. It is 5. And 21 times 5 is, off the top of my head, 105. So I get 105 from that. And then you look at these other three. Can I break them down? 15 doesn't break down and nothing comes out. 5 doesn't break down, 3 doesn't break down. Can I combine any of them, add them together? Do any of them have the same root? No, 15, 5, and 3 are all different roots. So I'm just going to rewrite it. Minus 7 square roots of 15 plus 6 square roots of 5 minus 2 square roots of 3. And that's your answer. Okay, these answers are kind of ugly for the most part, if you kind of noticed. There is one problem. This is our last problem we're going to do in this video. If I had the problem 2 square roots of 3 minus the square root of 5 times 2 square roots of 3 plus the square root of 5. Okay, if you notice, this should look a little bit familiar. So think back, if I have the same thing and my signs are different. We've talked about this before. This is called the, conjugate. And remember, we talked about the point of the conjugate is to make things go away. We did this with the i's. If we multiplied something by its conjugate, it made all the i's go away. You'll notice this actually makes all our radicals go away, and this is going to come in handy later on. So that's why I'm kind of introducing it now. So I do it the same exact way. I'm going to start off by multiplying 2 square root of 3 times everything in the other parenthesis. So 2 square root of 3 times 2 square root of 3 gives me 2 times 2 is 4. Square root of 3 times square root of 3 is square root of 9. 2 square roots of 3 times 5 is 2 square roots of 15. Now I'm going to do negative square root of 5 times 2 square roots of 3. That gives me negative 2 square roots of 15. And negative square root of 5 times positive square root of 5 gives me negative square root of 25. So this is a special case because all my radicals are eventually going to go away here. If I look at the first thing, 4 times the square root of 9. What's the square root of 9? 3. So this is 4 times 3, which is actually 12. Okay, 2 square roots of 15. Is there another square root of 15 I can put it with? Yes. Positive 2 square roots of 15 minus 2 square roots of 15. Positive 2 plus negative 2 is 0. Okay, so this is technically 12 plus 0 now. And then minus the square root of 25. Can I take the square root of 25? Yes, so minus 5. So 12 plus 0 minus 5 gives me 7. So notice that's actually a really pretty one. It turns out to be a beautiful whole number without any radicals, and it's because they were conjugates is the reason why. Okay, I hope that's helpful. You are now able to do your homework on MathXL for section 7.4. Please feel free to email me if you have any questions. I'd be happy to answer them.